Okay, let's dive into this explainer. Look, if you're a developer, you already know the tooling landscape is shifting beneath our feet, literally almost weekly. But today, we're going to put on our senior engineer hats and do a highly pragmatic, fluff-free evaluation of a massive leap in developer tool productivity. We're looking specifically at the newly released GPT 5.5 model and exactly how it integrates natively into the Warp terminal environment. Because let's be honest with ourselves for a second. Are you completely tired of babysitting your AI coding agents? I mean, we've all been there, right? You spend half your time doing heavy prompt engineering, explicitly detailing every single variable, and then you still have to hover over the terminal to make sure the agent doesn't hallucinate a random library or get stuck in some infinite loop. It's supposed to save us time, but constantly monitoring this output, it often feels like it just shifts our cognitive load from actually writing code to micromanaging a junior developer. So here's our tech spec evaluation for today. 1. Doing more with less. 2. Benchmarking the models. 3. Real-world coding demos. 4. The Warp terminal environment. 5. Automated code review loops. And 6. The Agentic Development era. All right, kicking things off with Section 1, doing more with less, or what we're calling the intent versus input paradigm. This is a fundamental shift in how developers are going to interact with large language models moving forward. The old way, and by old I mean literally just a generation ago with GPT 5.4, required rigid, highly specific instructions. You had to provide just an immense amount of context. But with GPT 5.5, the model has dramatically improved at inferring your underlying intent. You can provide a remarkably vague prompt, and it successfully navigates that messy intent to produce a calibrated working shape. It's essentially carrying way more of the cognitive weight itself, getting you much better results with significantly less input. And this efficiency, it translates directly into token economics. So the API pricing for GPT 5.5 sits at $5 per 1 million input tokens and $30 per 1 million output tokens. Compared to GPT 5.4, that price has literally doubled. But here's the catch that actually makes it a massive win for us developers. GPT 5.5 uses significantly fewer tokens to complete identical codex tasks. The sheer efficiency here means you're actually saving both time and computational overhead simply because the model requires way less back and forth to get the job done right. Moving on to Section 2, benchmarking the models. Let's look at some hard data on terminal performance. Now, what's really interesting about these numbers is looking objectively at terminal capabilities. We are seeing a massive leap. So terminal bench scores measure exactly how well a model executes commands and navigates an operating system. GPT 5.4 sat at a respectable 75%. But GPT 5.5? It jumps to an 82.7%. Crucially, it actually beats out Anthropic's notoriously unreleased Mythos model, which scored an 82%. Think about that. The model Anthropic claimed was too scary to release is currently being outperformed in terminal environments by GPT 5.5. But, we always need to look at the full picture. If we look at SweBench Pro, which is a really rigorous software engineering benchmark, Claude Opus 4.7 actually still competes heavily and edges out GPT 5.5. However, when we zoom out to the Artificial Analysis Composite Index, which aggregates 10 different hard benchmarks across coding, reasoning, and agents, GPT 5.5 Extra High breaks a previous three-way tie between Opus and Gemini. It becomes the definitive standalone leader. Objectively, across a blended workload, it's currently the smartest model available. All right, Section 3, real-world coding demos, taking this from benchmarks to actual execution. Because let's face it, benchmarks are just numbers until you actually deploy them. This source data highlights several highly complex tasks that GPT 5.5 executes completely flawlessly. I mean, it didn't just write a simple script, it successfully developed a fully functional 3D dungeon game and a 3D tank game. And beyond gaming, it seamlessly performed deep financial modeling directly inside an Excel spreadsheet. It even used the browser to independently test an onboarding flow for a website. Guys, these aren't just simple code snippets. These are complex, multi-step execution tasks requiring real, deep reasoning and tool use. Which brings us to Section 4, the Warp terminal environment. This is where the work actually happens. You see, an intelligent model is completely useless without proper environmental integration. You need a place to actually run it efficiently. Well, Warp has just rolled out universal agent support. This is the ability to run multiple AI agents side by side in real time. So within a single native dev environment, you can have Claude Code writing a new feature in one vertical tab, while Codex is simultaneously debugging a completely different branch right next to it. You don't have to change your workflow or toggle between 5 different CLI windows. Warp effectively transforms the standard terminal into a true command center for agentic development. And remember that babysitting problem we talked about at the very beginning? Warp addresses this directly with a unified notification system. Instead of constantly monitoring the terminal just to see if an agent finished a build or, got stuck, these sessions just run quietly in the background. The terminal only pings you when the agent genuinely requires human intervention or verification. It literally gives you your focus back. Next up is Section 5, Automated Code Review Loops, integrating AI right into the pipeline. Now, this is arguably the absolutely biggest time saver for any senior engineer evaluating this stack. So the crucial point here is how seamless this pipeline has become directly inside the terminal. Step 1, your agent writes the code. Step 2, you review it and simply leave inline comments right there in the environment. Step 3, the agent reads those comments and updates the code instantly. It's a completely self-contained automated feedback loop. You aren't copying and pasting blocks of code back and forth between a web browser and your IDE anymore. It all happens natively, exactly where the code lives. Finally, Section 6, the Agentic Development Era, a true paradigm shift in engineering. By synthesizing these massive leaps in model intelligence and terminal environment integration, we are genuinely stepping into a new era. In fact, when asked to describe its own strengths, GPT 5.5 generated this exact realization. Quote, "The sweet spot is not only answer generation, it is calibrated action, deciding what to expect, when to implement, and when to verify." End quote. It completely understands its own role in the stack. It is not just a fancy autocomplete anymore, folks. It's an execution engine. And this brilliantly illustrates the ultimate takeaway of our explainer today. Agentic development is a workflow paradigm where AI functions as a semi-autonomous collaborator. It executes, it reviews, and it handles complex, multi-step tasks directly within your native dev environments, like Warp. It takes the messy intent straight from your brain and turns it into working shape. And it does this requiring less input, fewer tokens, and zero babysitting. Which leaves us with this final thought. We've seen the benchmarks, we've seen the integration, and we've seen just how much cognitive load is being lifted here. So I have to ask you, if your terminal can now execute multi-step tasks and review code completely autonomously, what higher-level, complex engineering problems are you finally free to solve? Think about that as you configure your workspace this week. Thanks for joining me for this explainer, and keep building.